Moving on to lateral area and surface area of regular pyramids. And again, to remind you, when we talk about a regular pyramid or a regular prism, that means two things. It means it's a right solid, so it's not an oblique, slanted sort of pyramid. But it also means the base is a regular polygon. And we're going to come up with a formula for specifically those kinds of pyramids. If it's an oblique pyramid, or if it's the base is not a regular polygon, then you would just have to get the individual surfaces that you want and add them up. But when it's a regular pyramid, there's a nice formula. All of these triangles would be congruent on a regular pyramid. So the lateral area of this regular pyramid is the area of this triangle plus the area of this triangle plus the area of that triangle and the two in the back. But if they're all congruent, it's just going to be 5 times the area of each triangle. We don't use the pentagon because lateral area, remember, doesn't include the bases. So lateral area would just be the triangles going around. All right, so let's see. 5 times, so how do I get the area of this triangle here, for instance? Well, the sides are all congruent on that regular pentagon. So whatever this length S is, this side length is the same. So the area of this triangle is just 1/2 times its base, S, times its height, which is the slant height. And we can shuffle the order around when we're multiplying numbers together. And I feel like doing that. I'm going to shuffle the order around. 1/2 times 5 times S times L. I did that because 5 times S tells me something about that pentagon. If every side is every side is S and I multiply by 5, that's the perimeter. So 1/2 times the perimeter times the slant height is how we get the lateral area of any regular pyramid. If it was a regular octagon, the only difference is there would have been 8 triangles. That would have been an 8, that would have been an 8. 8 times S would have been the perimeter of that regular octagon. So this is for any regular pyramid's lateral area. Surface area, of course, is just going to be all of this plus the area of the one base on that pyramid. So those are the formulas we'll be using in the 4 examples I set up. Here's the first one for you to try. Can you hit the pause button and figure out the lateral area and surface area? We're going to round today to the nearest tenths. All right. So just like on the prism videos, I find it really helpful to start by drawing the base by itself. So in this case, and maybe you didn't need to where it was a square, but just to be extra clear, I did draw it out for you like this. So let me zoom back a bit. All right, so the base was a square. Every side length was 16. And using our area work, what we know about apophthegms and radii on regular polygons, the apothem bisects the side and the radius bisects the right angle in this case. So I had a little 45, 45, 90, legs both 8. So that told me the apothem of this pyramid, the base of the pyramid was 8. And if that's an 8, now using the Pythagorean theorem on this right triangle inside the pyramid, I can get the slant height. 24 squared plus 8 squared equals the hypotenuse squared. So that's the work I did over here, because I know I'm going to need that slant height for the formula. Now, just in case you, out of habit, simplified the square root of 640 to 8 root 10, I did write that out, but there's really no need to in this case because the instructions said to round off to the nearest 10, so this is going in a calculator anyway. So I would just leave it as the square root of 640, but either way is fine. So here we go. Lateral area, 1/2 PL. The perimeter of the base would be the perimeter of that square on the bottom. So 16 plus 16 plus 16 plus 16, 64. And the slant height from our Pythagorean theorem is there. Nearest tenths, 809.5. I forgot my units. Partial credit minus 1 point feet squared. All right. How about surface area? 1/2 PL plus the area of the base. In this case, the base is a square, so side squared is the formula we're going to use. So this is the same work we did before, 1/2 PL, but I'm just adding the square, 16 squared. So you put that in your calculator, 1065.5 feet squared. Here's number 2. All right, nearest tenths, what is the lateral area and surface area of this regular pyramid? That 20 is not the slant height. That 20 is this lateral edge, right? So it's this edge, one of the 3 sides of this triangle. So the slant height's not given on this one again. So see if you can figure out how to get the lateral area and surface area. All right, so for starters, I drew my base. That's where a lot of the work often winds up being. And I know that for the surface area formula, I'm going to need to get the apothem, because the area of that regular hexagon is 1/2 AP. So I started there. I drew my base, regular hexagon. I drew my apothem and my radius. And then using my n minus 2 times 180 formula, I calculated the interior angle sum for a hexagon is 720 degrees, divided by 6 congruent angles, because it's a regular hexagon, so these are each 120 degrees. Radius bisects that 120, so this is 60 degrees, so special right triangle, very nice. I know the apothem cut the bottom side in half, so that's 4. And if the short leg is 4, then my long leg is 4 root 3. There's my apothem. So that's one piece of the puzzle. Now I got to figure out how do I get my slant height. So if we look back at this original picture, there's a triangle there with 2 sides. Any one of the triangles there has 2 side lengths of 20. The lateral edges are 20, and the bottom of each triangle is 8. So I drew one of those triangles by itself, 20, 28, and I said I need to get the slant height. The slant height would be the height of that triangle. So just a little Pythagorean work here. I've got 2 congruent right triangles from hypotenuse leg. So L squared plus 4 squared equals 20 squared. And I did out my work, and I got the square root of 384. Again, no need to simplify it. You could if you wanted to, but we're rounding these answers off today, so there's no need. So I used the Pythagorean theorem to get the height there, to get the slant height, root 384. So now we're ready to substitute our values. Lateral area, regular pyramid, 1/2 PL. The perimeter of the base, well, if every side length is 8, and it's a regular hexagon, 8 times 6, 48 is the perimeter of the base. And I just showed you the Pythagorean theorem, got me my slant height. So 470.3 centimeters squared. Surface area, as you can see, more work here. 1/2 PL plus area of base. And the area of the base, in this case, is 1/2 AP. That's the formula for regular hexagons. So if I substitute the perimeter of 48, the slant height of root 384, the apothem that we got from our special right triangle up here, 4 root 3, and the perimeter again, because it's 1/2 AP, so I'm using the 48 twice. And you could just put that in your calculator. I chose to simplify a little bit first, but final answer, 636.6 centimeters squared. All right, 2 down, 2 to go. Number 3. Regular pyramid, height 8 meters, slant height 10 meters. Can you find the lateral area and surface area to the nearest tenths? So what made this tough for me was we need the perimeter of the base and the area of the base, and none of this given information is about the base. We don't know the perimeter, we don't know a radius, we don't know the apothem, we don't know a side length, so somehow we're going to have to be able to figure out something about a dimension in that base using what was given. And eventually, hopefully, you realize that if we draw the slant height, and if we draw the height, then there's this right triangle inside the pyramid. And we know 2 of the 3 sides of that right triangle. We know the height is 8 and the slant height is 10. This is 8, this is 10. Pythagorean theorem will tell us that this has to be 6. And what is that segment that connects the bottom of the height to the bottom of the slant height? What is that 6 on the base? That is the apothem. So here it is. So there's the right triangle that I just had in red. The bottom side of 6 is the apothem. So now when I draw the base by itself, we know the apothem is 6. N minus 2 times 180 tells me the interior angle sum is 540 degrees. Divide by 5, 108 degrees for each interior angle on a regular pentagon. Radius bisects, so 54 degrees. All right, so I've got a right triangle. I can do some trig here and I can get the missing information I need. The tangent of 36 is opposite over adjacent, so x over 6. Which means x has to be 6 times the tangent of 36. Notice I didn't round that off. X is 6 times the tangent of 36. So one side of the pentagon would be double that, 12 times the tangent of 36, which means the perimeter would be that side length times 5 sides there. So 60 times the tangent of 36 degrees. We now have all the numbers we need. So if you need to go back and watch how I got the apothem or how I got the perimeter, go ahead. But I'm going to move on to substituting the values. So here's the lateral area piece, 1/2 PL. The perimeter was 60 times the tangent of 36 degrees. The slant height was given to be 10. Crunch your numbers. I did some simplifying. 300 tangent of 36, or 218.0 meters squared. That's rounded to the nearest tenths. Now for the surface area, it's going to be all the same work plus the area of that pentagonal base. So that looks like this. Surface area is 1/2 PL plus the area of the base. The area of the base is 1/2 AP. So here's the 1/2 PL that we did up above, but I'm adding 1/2 apothem perimeter. And you could type all that in your calculator and get this answer down here, or you could do some simplifying like I did. Final answer, 348.7 meters squared. Here's the last one. Kind of a neat one. This is a regular tetrahedron. So it is a pyramid. So what is the lateral area and the surface area? All right, 2 ways to do it. Here's the hard way. Hard way is, well, say, well, if I'm going to use the 1/2 PL formula, I need to know a slant height. And if I'm going to be getting the area of the base, I need to do 1/2 base height for the area of a base. So every triangle in that picture was an equilateral triangle with side lengths of 8. Right? They're all the same triangle. So here's the base. And if I want to figure out the height in order to later do 1/2 base height and get the area of that triangle, I can draw the height, and knowing that an equilateral triangle has 60-degree angles, I created a 30, 60, 90. Short leg 4, so the long leg, which is the height, is 4√3. But that's also the slant height if we think of one of the other faces of the pyramid, such as this one. If we're thinking of this triangle, the slant height would be here. Let me get that in focus. So this is the slant height, but it's also the height of that triangle. So it's really the same work. There's no need to do it twice, but there it is. The slant height is 4√3. All right, so if I'm doing 1/2 PL, the perimeter of one of those triangles is 8 plus 8 plus 8, 24. The slant height we saw is 4√3. Half times 24 times 4 is 48, so 48√3 is 83.1 inches squared. Surface area is going to be all of that plus the area of the triangle on the bottom. Now again, this is the hard way to do this one. There is a better way coming up. I'm hoping some of you did it the better way. Not better, but faster. 1/2 PL plus B. 1/2 PL plus area of the base, which was a triangle, 1/2 times the base times the height of the triangle. So there's my perimeter, there's my slant height, and looking at one of the triangles, the base is 8 and the height is 4√3. That came from here. Base is 8, height is 4√3. So if you go ahead and simplify and grab your calculator, you will get 110.9 inches squared. That's the hard way. What's the fast way? We have a special formula for equilateral triangles that is not in your textbook, but we learned it way back in the area chapter. Who remembers the 2, 3, 4 formula? Side squared √3 over 4. How about this way instead? Lateral area is just the area of, not the base, but the other 3 triangles going around. 3 times the area of an equilateral triangle. Equilateral triangle is 8 squared √3 over 4. 8 squared over 4 is 16. So 3 times 16 √3, 48 √3. That's the same answer we had, 83.1. And even better, look at this. Surface area would be the 4 triangles, all 4 equilateral triangles. That's what this picture is. It's just 4 congruent equilateral triangles. So why not just do side squared √3 over 4 times 4? And look what happens. Those 4's cancel. It's just s squared √3. That's a formula for a regular tetrahedron surface area, s squared √3. So you fill in your 8 and you get 64 √3. Same answer we had over here, 64 √3, or 110.9 inches squared. All right, good luck with your assignment.